Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, hello. Welcome to another video on organic chemistry. In this video, we will be continuing our lessons on organic chemistry by learning how to name some of the hydrocarbons that we have looked at already. Okay, so in our initial video, we looked at what organic chemistry is. We looked at what hydrocarbons are. We looked at the properties of carbon and why carbon is important. We looked at what we call aliphatic compounds. Okay. We looked at what we call aliphatic compounds and compounds. And we discussed what makes up those aliphatic compounds, and we saw that aliphatic compounds is made up of alkanes. It's made up of alkanes. We saw that aliphatic compounds made up of alkenes. And we saw that aliphatic compounds are made up of alkynes. And we saw that all these three groups are distinguished by the number of bonds between adjacent carbons. And we established that the number of bonds between adjacent carbons in our alkanes is always 1. And we established that the number of bonds between alkenes between at least one, the number of bonds between at least one pair of adjacent carbon atoms in alkenes is 2, and the number of bonds in at least one pair of alkynes is 3. Okay, so all of this was covered in a previous video, and if you would like to revise on that, it would be a good point now to pause this video and go back to the previous video. Okay, so in this video, excuse me, just a bit sick. In this video, we'll be continuing our lesson with looking at these aliphatic compounds, and we'll be basically focusing on naming these aliphatic compounds. So we will be naming alkanes, alkenes, and alkynes. Okay, different alkanes, different alkenes, and different alkynes. We'll be drawing them out and figuring out how to go about naming them. So let's get that show on the road. Now, before we actually start naming these compounds, there are some rules, right? There are some rules that we are going to follow. We need to follow these rules in order for us to be able to name these compounds. In order for us to be able to establish what the name of each compound that we'll be looking at is, we're going to have to apply the same set of rules to all of the compounds, okay? So that we can find an easy way to know what compound we're talking about, and we can find an easy way basically to come up with a name for it. Okay, so what are those rules? Well, those rules are, when you name a person, right? When you name a person, if you've got a person here and you want to give a name to a person, that person has a first name, right, and a surname. Okay, person has a first name and a surname, and the first name constitutes a part of that name, and the surname constitutes a part of that name, right? So it means that this name, if a person has a name, so for instance, if your name is John, right? If your name is John and your surname is Smith, right? Or if your name is Lerato and your surname is Vilakazi, right? Then you will agree with me that you can have these names and surnames in any combination, right? You could have a John Vilakazi and you could have a Lerato Smith, right? Unlikely that you'll find a Lerato Smith or a John Vilakazi, maybe more likely. But yeah, you understand what I'm saying. What I'm saying is you could have these names in any different combination. You could have a John Smith or John Vilakazi. You could have a Lerato Vilakazi or a Lerato Smith, right? Okay, so it's basically the same with our organic compounds. Our organic compounds have names, what I will refer to as names and surnames. Okay, they have names and surnames. So the fancy word for the names, I'm just going to say names here. And then I'm going to have surnames here. Okay, I'm going to have surnames here. Okay, now by names, I mean what in English we call prefix, right? We call prefixes. Okay, so the names are what we refer to in language as prefixes. It's basically a word that it's the first part of a word that we can use with a bunch of different other words. Okay, so something like anti-clockwise, right? I say anti. If I say anti-clockwise, the prefix is the anti, because you can use the word anti. You can use the word anti with a bunch of other words, right? And we know that anti means the opposite of, or in contrast to, or against, right? We know that anti means a certain thing. So this is what I would refer to as the name, right? And then clockwise is what I would refer to as the surname. Okay, so this is basically a prefix. Okay, so whenever you're writing tests and surnames, don't actually call it a name, the first part, these words that I'm going to give you, because I'm just using that because I'm explaining here now. So, okay, so now for our hydrocarbons that we'll be looking at, our aliphatic compounds, our alkanes, alkenes, and alkynes, we've got what I'll refer to as names and surnames. Now, what are the names that I'm referring to? What names do we have for these compounds? Well, we're basically going to be focusing on 8 names, right? We're basically going to be focusing on 8 names. In this video, we'll be focusing on 8 names, and we will be focusing on 3 surnames. Okay, we'll be focusing on 8 names and 3 surnames. Now, what is the first name? Well, the first name is what I will call myth, right? Myth is the first name that we will be focusing on. Myth, right? It's the first part of the word, so I'm going to put in a dash there to show that it's an incomplete word. So you take this myth and you combine it with another word to form a complete word, right? As a matter of fact, I'm going to put in a column in between here to indicate something, to indicate what this word means. Now, remember when I spoke about anti-clockwise, right? When I spoke about the word anti-clockwise, when I wrote the word anti-clockwise, I said to you the name of this would be anti. This would be the name. This is what I call the prefix. And we know that this means the anti. The anti means against, right? So what is my point? The point that I'm trying to make here is that the name means something. It means something. It has a meaning behind it. When you put in that name has a meaning behind it. Okay, just like you when your parents named you, they named you because of a specific reason, and that reason holds a great meaning to either them or you, or to both of you guys. Okay, you and your parents. So it's the same thing with organic compounds. We've got names and surnames, and these names mean something very important. Okay, now what does myth? If myth is my name, what does myth mean? Myth means one. It means one of. One of what? Well, I will tell you as this video progresses. Okay, it means one of, right? It means one. So whenever you see myth, just think of one. I want you to associate it with the number 1. Okay, this you'll have to remember somehow. You should find a way to remember it. Okay, and the second word that I'm going to give you, the other name is if, right? And if means 2. That's what if means. It means 2. Okay, let me just extend that a bit further down. If means 2, right? What is the next name that I'm going to give you? The next name is prop. Okay? Remember I said I'm going to give you 8 names. Prop means 3. The next name is but. Okay? But means 4. The next name is pent. Pent means 5. The next name is hex. Hex means 6. The next name is hept. Okay, hept means 7. The next name is oct, and this is the last one that I'm going to focus on. And oct means 8. Okay, so these are the 8 names that I want you to remember. Remember, these are the 8 names, and these 8 names mean something very important. They mean something very important. What is that important thing that they mean? Myth means 1. If means 2, and so on and so forth, right? This is what these names mean. Now, 1 word, 2 words, 3 word, 4 word, 5 word, 6 word, 7 word, 8 word. I will tell you what those words are. But firstly, before I tell you what they mean, what about the surnames? What about the surnames? I told you that we'll be dealing with 8 names, 8 first names, and then 3 surnames. Now, when we're dealing with these aliphatic compounds, the 3 surnames, right? The 3 surnames are Ain. The first one is Ain, right? It's not in line with this first one. Actually, let me try to separate. How do I separate this? Okay, so the names that I'm writing here do not line up with these, right? They don't line up. So they're just 3 surnames. So the surnames are Ain. Okay, just write them up here. That's the first surname is Ain. The next surname is In. And the next surname is Ein. Okay, now remember what I did with John and Lerato, and I had Smith here, and I had Vilakazi here, right? I had Vilakazi here. I said that I could use this with that, and I said that I could use this with that, or I could use these as they are, like that. Okay, these are names of people, popular names of people. Now, I can do the same thing with these names here. These names are very important, but I can use these names in any combination. I could have this name and use it with that surname. I could use this name with that surname. I could use this name with that surname. The same goes for all the other names. For all the other names, I could use if with that surname, or with that surname. Okay, very same thing with prop. I could use this with that, with that, with that. To form what? To form full names. Remember, what makes up a full name? It's a name and a surname. So if my name is Myth, right, and my surname is Ain, then I can form a full word that is called methane, right? So now and in this case, I know I said I'm dealing with names and surnames, but in this case, I write it as one word. I don't have to separate them like we do with the names of human beings, right? I write it as one, and I have methane, right? I could do this with any number of names and surnames here, or prefixes and suffixes. We call these, in English, we call these suffixes. Okay, suffixes, which are basically words that come last in a word, last part of words with a meaning. Okay, but never mind, that's English. So we've got that. So I could do the same thing, say, for instance, with prop, and I could combine it with that to get what? To get propine, like that. Okay, I could do this with all these words that you see here. So this sheet that you see currently is very important because it has all the names and all the surnames that you're going to use in this video to name your different hydrocarbons. Remember, the main aim of this video is to name your aliphatic compounds, and this is part 1. I will have more parts with this video to name more complex versions of these aliphatic compounds, but I'm going to start with the simplest in this video. And you have names and you have surnames, right? Now, how do you go about naming these compounds using these names and these surnames? Remember, I told you that these names have meanings, right? Meth means 1, eth means 2, prop means 3, but means 4, pent means 5, hex means 6, hept means 7, and oct means 8. Okay, and for you to use these things, you're going to have to understand what these numbers mean. What do these numbers mean? Well, what section are we looking at now? We are looking at organic chemistry. And what did we say organic chemistry is about? Organic chemistry is the study of carbon-based compounds. The study of carbon-based compounds. So the important element that we're looking at is carbon, right? Carbon is the most important element when we're dealing with organic chemistry. So these numbers here represent the number of carbons. These numbers here represent the number of carbons that we're looking at. Okay, now, since they represent the number of carbons that we're looking at, we know that the names that we get are somehow related to carbon. Okay, they're related to carbon. Now, how are they related to carbon? Well, meth means that there's one carbon, eth means that there's two carbons, prop means that there's three carbons, and so on and so forth up until 8, where 8 means that, oct means that there's 8 carbons, right? So if you have, remember we dealt with our aliphatic compounds, and our aliphatic compounds are what? I have them up here. I'm not going to rewrite them actually here. I have them up here. Our aliphatic compounds are alkanes, alkenes, and our alkynes, right? And our alkanes look like that. Between any two adjacent carbons, you've got a single bond. For our alkenes, between any two adjacent carbons, you've got a double bond, okay? At least one double bond. And for alkynes, between at least two adjacent carbon atoms, you've got a triple bond. Right, now we want to name these alkanes, these alkenes, and these alkynes. Compounds that make up alkanes, compounds that make up alkenes, and compounds that make up alkynes. How do you go about doing that? If I go back down here, you will notice that what I call surnames on the right here, what I call surnames are actually very closely related to these three aliphatic compounds. What are my aliphatic compounds? My aliphatic compounds are alkanes, alkenes, and alkynes, right? Alkanes have that surname there, ane, right? You notice that. Alkenes have that surname there, ene. And alkynes have that surname there, ine. Okay, so we know that. Okay, so ane actually represents alkanes, ene represents alkenes, and ine represents alkynes. Okay, now let's actually start naming these compounds. Okay, so cool. I know that ane represents alkanes, ene represents alkenes, and ine represents alkynes. Now I've got all of this information here. This is overwhelming. This is just too much information. We're just getting a lot of information and we're not actually using it. Let's actually start using it and naming these compounds. Okay, let's actually do that. It's very easy. It's very simple to follow. Now we know that I'm going to start off with alkanes, right? I'm going to start off with alkanes. Or let's say an alkane, one alkane. I'm just going to do one or two examples. Okay, let's say alkanes. So if I start off with alkanes, we know that between any two adjacent carbons, I'm going to draw two, right? Atoms. I've got one bond, or a single bond. And I know that the rest, because this is a hydrocarbon, this is going to be H, 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 and H. Now, what is the name of this compound? Here's what you do. Now we can apply the rules that we have on our first page. Remember what the rules are. Firstly, what aliphatic group does this compound fall under? It falls under alkanes, right? So, okay, cool. We know that since it falls under alkanes, it will have this surname, ane, because it falls under what? It falls under alkanes. So the surname will be ane. So I'm just going to write the surname. I'm going to say ane because it falls under alkanes, right? How do I know that it falls under alkanes? Because all the bonds are single bonds. You can see all the bonds are single bonds. And we know that for alkanes, the bond between any two adjacent carbon atoms is a single bond. So specifically this bond, this is a single bond. So it's an alkane. Therefore, the surname is ane. But what is the name? We're dealing with names and surnames here. What is the name of this compound? If I go back up here, the name of this compound is, okay, cool. Let's go back down to this compound. How many carbon atoms does this compound have? This carbon atom has this compound has two carbon atoms, right? So it has two. Therefore, where's my two there? Here's my two here. My two is related to the eth there. So the name of this compound is eth, right? Eth, the first name of this compound is eth. So I'm just going to write eth here, E-T-H, because that's the prefix, that's the eth, that's what's on the left hand side of the column. And therefore, the full name of this compound is ethane. You can see it here. The full name is ethane. Done. Solved. problem solved. This is the name of this compound that you're looking at. It is ethane, right? Let's do another example. Let's do a second example. Let's try to come up with another compound. Let's say you've got C, C, C. Then you've got, remember, all the carbons should have 4 bonds around them. This was in the first video. If you missed the first video, please have a look at the first video. You should have 4 bonds around all the carbon atoms. Okay, how do we name this? Well, is this, what kind of aliphatic group does this fall under? Is it an alkane, alkene, or an alkyne? Well, all the bonds, right, in this compound are single bonds. Since all the bonds are single bonds, what do we know about an aliphatic group with single bonds? If you go back to the first page, single bond, there's a single bond there. They are alkanes. So that falls under the alkane. If it falls under the alkane, what is the surname? The surname is ane. If the surname is ane, I'm going to go back down to this and I'm going to write it here. The surname is ane. Okay? What do I know about the name? Well, firstly, I know that the name is related to the number of carbon atoms in the compound. So the name is, let's establish that. We've got how many carbon atoms? 1, 2, 3. We've got 3 carbon atoms. Since we've got 3 carbon atoms, I'm going to go back up to my table. There's my 3 there. And I know that 3, the name of my 3 is prop. Okay? The name of my 3 is prop. So I'm just going to take that name and put it together with the surname. So the surname is, the name is prop. The surname is ane. So therefore, the name of this compound is propane. Propane. Easy. Easy peasy. Okay, so that's how you would name this. Let's do a different compound. Let's do a different compound. Okay. Different compound. Let's say you've got C, then you've got C, then you've got C here, and then you've got another C here. Then you've got H. By the way, your chains don't have to be straight, right? They could be branched. They could turn like this. They don't have to be straight. Just because I put in the C down here doesn't mean that it's something different. Okay, so they don't have to be straight. And I'll cover more on that in a separate video. But let's say you've got this compound. You've got this compound here. Okay, cool. What is the name of this compound? It looks complicated. It's not complicated at all. It's not complicated at all, right? Okay, so we've got a chain of carbon here, carbon atoms. We've got a chain, a straight, chain. We've got a chain, a complete chain of carbon atoms. Okay, but first thing that we want to do is we want to establish what is the surname of this compound. You can start with the name of the surname. It doesn't matter. What is the surname of this compound? Well, we see that the number of bonds in these 2 adjacent carbons here is 2, right? The number of bonds here is 2, right? Since the number of bonds is 2, what do we know about the aliphatic group with 2 bonds between adjacent carbons? We know that they are alkenes. Therefore, if they are alkenes, what is the surname of that compound? The surname of the compound is ene, right? Because it's an alkene, the surname is ene. So I'm going to come back right here and I'm going to say dash E-N-E. Okay, I'm actually not going to write down the dash. It's E-N-E. We know that that's the surname. What is the name? Remember how we established the name? We just count the number of carbon atoms and then we go find the name. So how many carbon atoms form this chain? Well, it is 1, 2, 3, 4. 4 carbon atoms form this chain. Therefore, let's find the name that's related to 4. The name that's related to 4 is bute. Okay, the name that is related to 4 is bute. Therefore, the name of this compound is butene. The full name of this compound is butene. Done. Easy. You use the same exact rules that you used for your alkanes, but this is an alkene. It's an alkene. Why is it an alkene? Because it has a double bond, okay, between those adjacent carbon atoms. Let's do a separate one, another one. let's say you've got let's say you've got this, 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 and you've got this. You've got this, and you've got this. This is H. Remember, 4 bonds around all your carbon atoms, just 4. 4 bonds around all your carbon atoms, right? So if you count the number of bonds around all the carbon atoms here, it's going to be 4. It should always be 4, right? That should be something that you should be used to by now from the first video. Okay, so now how do we name? What is the name of this compound? Same exact rules. It looks a bit more complicated. It's not. The same exact rules that we've been using. Let's first establish what the surname is. Okay, the surname, remember, is related to the number of bonds between all the adjacent carbon atoms. Now, I know that the biggest number of bonds, the maximum number of bonds that I have between any 2 adjacent atoms is 3. I've got 3 bonds there between those adjacent atoms. I know you've got a single bond there, single bond there, single bond there, but you want the maximum number of bonds, right? Between any 2 adjacent atoms or 2 carbon atoms that are close to one another, that are next to one another, right? That's what I mean by adjacent, and it is that, okay? And then it's between that carbon and that carbon, right? Those are the adjacent carbons. So what is the surname of this? Well, what we know about 3 bonds between 2 adjacent carbon atoms, 3 bonds, we know that it falls under the aliphatic group, the alkynes, right? Therefore, what is the surname of that compound? Well, the surname is -ine, right? The surname is -ine. Therefore, I will put in -ine there. Okay, now what is the name? What is the official first name of this compound here? If this compound was a person, their first name would be what? Remember, the name is dictated by the number of carbon atoms. How many carbon atoms do I have here? I've got 1, 2, 3, 4, 5. I've got 5. Therefore, I go to my little table that I drew out there. This table that you have to memorize this table. Unfortunately, you've got to memorize it. 5 carbon atoms. There's my 5 carbon atoms. The name that's related to 5 carbon atoms is pent. Therefore, this is going to be pentyne. Pentyne. Okay, this is going to be pentyne, and that is the name of this compound. Easy. Okay, I want to do a bunch of examples now so that it's easy to understand, it's easy to follow, and that we'll get a bit more complex in the next video. But in this video, this is as far as complicated as this is ever going to get. Okay, in this video. So let's say you've got this now. The simplest one that you ever going to come across in organic chemistry. What is this one called? Easy. How many bonds do we have between any 2 atoms? We've got a single bond each time. Everywhere we've got a single bond. Since we've got a single bond, what do we know about the aliphatic group with single bonds? We know that the aliphatic compound with single bonds, the aliphatic group is alkanes. Now, since we know that it's alkanes, what is the surname of that compound? It is ane. And since we know that ane is the surname of the compound, we can write it down right next to the compound. I'm just going to say ane. What is the name of the group? The name of the first name? Well, the name of the first name depends on the number of carbon atoms. How many carbon atoms do I have here? 1. Therefore, the name of my carbon atom is the name that is related to the 1, and that is that meth there. Therefore, if I take that first name and I combine it with that surname, then what I have is methane. Therefore, the name of this compound is methane. Okay, it is methane. Easy. It doesn't get any more complicated than that. Let's do another one. Okay, we're going to complicate things in the next video, but now let's keep them simple. Let's get used to this. Right, so we've got that. Let's say we've got that. 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 Okay. Then we've got H. we've got H, 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 H. And you look at the number of bonds around any carbon atom, that's going to be 4. Any carbon atom that you look at, it has to have 4 bonds or 4 lines basically attached to it. Okay, you can check, right? For instance, this one has this line 1, 2, 3, and 4. That's 4. For all the C's, they should be surrounded by 4 lines. All the C's, right, should be surrounded by 4 lines. What is the name of this compound? Well, the name of this compound, firstly, let's start with the surname, right? Before I establish the full name, let's establish the surname. Remember, the surname is related to the maximum number of bonds between any 2 carbon atoms that are next to one another. Right, here is my maximum number of bonds, and it's between these 2 carbons. Right, and this is a complete chain. Notice that this is a complete chain, right? If I draw a line, I can draw a line through all the carbons without missing any carbon. So it's a complete chain, right, of carbon. There's no other carbon anywhere. It's a complete chain, even though it's not straight, even though it does that down there. It's still a chain. As long as I can draw a line through all the carbons without lifting my hand or without lifting my pen, then it's a complete chain, right? How do I name this? Well, the way I name it, how do I name this compound? Well, you've got the surname and the first name to give you the full name. What is the surname? Double bond there between 2 adjacent carbon atoms. Since I've got a double bond there, what do I know about my aliphatic group or aliphatic compounds with a double bond? We know that it's called alkenes, right? And what is the surname of my alkenes? Well, the surnames of my alkenes are -ene. They are -ene. And so I know that this compound, the surname of this compound, before we establish the full name, the surname of this compound is -ene, right? It's -ene. Now, let's go. What is the first name of this compound? The first name of this compound, if you look at this compound here, the first name is established by the number of carbon atoms. What is the number of carbon atoms? You've got 1, 2, 3, 4, 5, 6 carbon atoms. Since you've got 6 carbon atoms, we try to find the first name with 6 carbon atoms, and the one with 6 carbon atoms is that one there. It's hex, right? So then this is gonna be hexene. This is gonna be hexene, right? So this is the name and the surname of these compounds. This is how you establish the name and the surname of these compounds. It's very easy. It's very simple. It's very easy to follow. But now we've got a little complication here. We've got a little complication, and I will handle this complication in the next video, but let me introduce it while I'm still here. Now, what if you've got, right, if you look at this compound here, this is what it looks like, right? But what if this double bond here was somewhere else? What if it wasn't here? What if instead of here, this double bond, when I remove one line, what if this double bond was somewhere else? What if it was here, right? If it was here, then remember all your C's must be surrounded by four single lines. So then this would go away, so that you're surrounded by 4. But what if it was there and it wasn't where I put it in initially, and then here you've got an H? What if this was what it looked like? Or what if it wasn't there? What if it was somewhere else, right? What if it was, if I put in that there, what if it was here instead? Right, what if that double bond was there? What if, because it could be there, right? The same applies for the compound that we covered earlier on, this compound here. What if this triple bond here was somewhere else? What if it wasn't here? What if instead of here, it was here? Right, let's do this. What if it was here? Right, this triple bond. So therefore here you wouldn't have this and you wouldn't have that. What if it was there? Because it could be, right? It could be. It's still this, make no mistake, this is still pentyne. This is still pentyne, it doesn't change, but we must add something to this name in order to establish where exactly the triple bond is. Okay, so in order to establish where this is exactly, we have got to add something to this name and this surname, right? In order to establish this is hexene. In order to establish where exactly along this chain this double bond is, we've got to add something to this hexene. We've got to add something to this hexene. Okay, this is still hexene. Make no mistake, it's still hexene, but we've got to distinguish the difference between a hexene that has a double bond here, or a hexene that has a double bond there, or there, or there, or there. We've got to distinguish the difference. How do you distinguish the difference between that? We will cover that in the next video. Okay, we will introduce more to our naming system or to our rules in order to know how to distinguish between these compounds where they have differently placed double bonds or triple bonds. Okay, so as far as this video goes, this is the simplest this is as simple as it's ever going to get when it comes to naming your hydrocarbons. It only gets a bit more complicated than this. Not difficult. Complicated doesn't mean difficult. It's very, very easy. It's just we're going to add more rules to these rules that we've already established in order to come up with a better naming system that will give us more information about the compounds that we're dealing with. Okay, it's still going to be very easy. It's not going to be difficult to follow. It's still going to be very, very easy. But in the next video, we will cover that. But just in this video, just familiarize yourself with this table, memorize it, know how to come up with it, understand what it means, understand what your aliphatic compounds are, understand about the bonds for each of your aliphatic compounds, understand the naming system, the rules, and understand how to apply them and when to apply them and when not to apply them, and familiarize yourself with this. Once you are happy and you are familiar with this stuff, then we will make it a bit more interesting. Okay, make it a bit more fun. Okay, so I'm going to stop here for this video. Till next time.